Hello, this is Mr. Harris. This is the video for pages 15, 16, and 17 of the conic sections and polynomials units. I will have a video or a quiz posted through the TED-Ed website asking you specifically what A, B, and C does to a quadratic equation. We're going to look at the vertex and zeros of quadratics, and also we are actually going to derive the actual quadratic equation. Like Al-Khwarizmi derived it in 850 AD in Baghdad, Iraq. Algebra is named after Al-Khwarizmi, if you haven't read it. These are just examples completing the square. These are some examples of completing a square when A is a number other than 1. Solve for 0 by completing the square, find the vertex, sketch a quick graph. So I'm just going to go ahead and solve for 0 via completing the square. I have 4x squared over 4 plus 8x divided by 4 equals positive 5 divided by 4, because everything has to be equal to 0. 0 is the base mark, the status quo. Okay, so we get x squared plus, do I want to keep this? I'll keep this as 2x equals 5/4. I'm going to have to keep this in mind that I did divide everything out by 4. Another way to even go about this, which actually might be easier, would be simply to factor out 4 here. So I do 4 times, in this case, x squared plus 2x plus blank equals 5, without dividing everything by 4, just like we did with the ellipses and hyperbolic functions and all of those. I think I'm going to stick with this method because this method will make more sense. Because when we're talking about vertex form of an equation, h squared plus or minus k, we're talking about things like that. So having that a right here makes sense to me. When I'm talking about a, I mean y equals a times x squared plus bx plus c equals 0. In this case, the zeros are when y is 0, what is x? So I'm going to stick with this because I think it'll be easier for me. Things will work out. I'm pretty confident that they will. So let's first figure out what our b over 2 squared is. In this case, now a is 1, but remember when we add to this side, we have to multiply by 4. 2 divided by 2 squared is 1. So that's 1 squared, and that's 5 plus 4 times 1 squared. So that's 4 times x plus 1 squared equals 9. If we write it in vertex form, 4 times x plus 1 squared minus 9 equals 0. So I'm thinking the vertex is somewhere at -1, comma, -9. And it's going to be stretched vertically by a factor of 4. It's going to quadruple relative to the parent function. Let's go ahead and solve and get these roots. X plus 1 squared equals, now we have 9 divided by 4. X plus 1 equals plus or minus square root 9 divided by 4. That's the same thing as x plus 1 equals plus or minus, we can rewrite this as square root of 9 divided by square root 4, or 3 divided by 2. So we have x plus 1 equals plus or minus 3/2. And I'm just going to subtract 1 from both sides. So x equals -1 plus and minus 3/2. So we have the two solutions. To sketch the vertex, we have is -1 comma -9. To sketch a quick function, -1, -9 is way down here. -1 plus, I'm going to write this as 1.5. -1 plus 1.5 is positive 0.5. So we have a point here. -1 minus 1.5 is -2.5. So if that's 1, 2, 3, negative 2.5. Vertex, we have our zeros. And again, you need 2 points to graph a line. You need at least 3 points to graph a parabola. Generally speaking, that 4 multiplied compounded by 4 would have a lot to do with these because it has everything to do with in terms of how it's stretching. I'm going to post the answer to these in this link so you can check. Let's just look at these answers. Let me share this screen. Dun, dun. There it goes. So we have our vertex at -1, comma, -9. We have our solutions. Remember, we have positive 0.5 or 1/2. And our other solutions at negative 2.5. 2 goes into 5 2 times with the half left over. So that's the same thing as negative 2.5. Those are our solutions and they're moved up. In this situation, the parentheses are missing, but you can still figure out what we did here. For A, for the next term, when we're dividing or working out this -2, I would again factor out a -2, leaving a positive 5 here. If you notice, you get the same answer either way. And then in this case, when we solve, you can't take the square root of a negative number, so that means you have imaginary numbers. I'm going to solve this in my calculator just to remind you all how to get vertices and everything in the calculator. And then next, we're going to look at graphing imaginary numbers. There are imaginary solutions, but like they said, they are actually imaginary numbers. So you have to consider them as such. Let's first go to graphing that. F of x. Okay. -2x squared minus 10x plus 9 graph. Okay, I'm going to adjust my window so I could see the peak, the vertex at the top, the maximum value. Let's make the y maximum 20. Okay, so we'll make the y maximum 30. Okay. Just to verify let's find the maximum value first. Second calc. It's a maximum because it's at top of a valley or top of a hill, Left bound. Right bound. Guess we don't need to do anything. Let's look at this maximum value, -2.5, 21.5. Let's verify. Yep, -2.5, half of 43 is 21.5. Okay. And again, if we wanted to get the zeros, I'm just going to find this one, left bound, move the cursor slightly to the left, enter slightly to the right of the zero we're looking for, enter, enter. There you go. That's one of the zeros we have. It's a funny odd number, but it's a funny odd number. That's why when you're setting up answers in terms of radicals, leave it as a radical because a radical is the exact answer. If not, you have these really long numbers. Let's look at these numbers again. Yeah, it's much better to leave the numbers like this. Yeah. Okay. So now let's get the other root, 0. Move it slightly to the left of the other 0. Enter slightly to the right, enter, enter. And there we go for the other root. Wonderful. Okay. Now let's look at the other solution, the third one. I'm going to work this out and quickly sketch approximately where that solution would be. X minus 3 squared equals -4. So when we have x minus 3 squared equals -4, x minus 3 equals plus or minus square root -4. That's why mathematicians introduce I. Imaginary numbers are a way to work around what we cannot do. So it'll be plus or minus, remember, pluck out the I, square root of 4, or x minus 3 equals plus or minus 2I. That's why complex numbers always come in pairs, because the plus or minus, x equals positive 3 plus or minus 2I. So sketching this function, vertex at -3, +4, 1, I'm sorry, +3, because remember we do the opposite if it's inside parentheses. 1, 2, 3. We set this equal to 0, 1, 2, 3, 4. So that's 4, that's 3. It goes up. We know it has no solutions because it's floating up. To plot imaginary numbers, we go out to 3, and we go up based off of whatever the coefficient of I is. So we go out to 3, and we go up 3 plus 2, 1, 2, and we don't put a solid dot, we put an open circle, indicating that it's an imaginary number, it's not a real value. So generally speaking, with complex numbers, you have a plus or minus bi. A lot of people will write as x plus or minus yi. The term without I indicates your horizontal displacement, your x value. Your term with the I indicates your y value. Essentially meaning, if it wasn't for it floating up above the x-axis, there would be a solution if it was grounded, but it's not. The other solution, we go out 3, and we go down 2. Go out 3, plus 2, go out 3, down 2. And these are the imaginary solutions to this graph. So even this has 2 solutions, hence the degree of 2. They're just imaginary solutions, and definitely they float underneath that graph. It's almost like, hey, why is that guy floating? Oh, there's like some extraterrestrial something or another propelling it, magnetic propulsion nonsense going on. Well, I shouldn't call it nonsense, that's the wave of the future. But that's one way to view complex numbers. Yeah. So that's it. Tutoring starting now. So I'm going to end this video, and the next video will be deriving the quadratic equation and essentially breaking down, dissecting the quadratic equation. Ax squared plus bx plus c. See you in a moment. Goodbye.